Namaskar. In my last lecture series on calculus, I have explained the concept of limit. We have already studied the calculus. What is calculus? What is limit? Why calculus is an important tool in science and engineering applications. Although calculus is invented by Newton and Leibniz, but after that there are various applications. We have seen that how calculus plays an important role to understand the nature in different scenarios, in different phenomena. Thus, calculus is a beautiful and creative concept. In my last lecture, I developed a particular methodology to explain the limit. This lecture is in continuation of the last lecture. If you understood the concept of limit, then the question will raise that how you find the limit, how you compute the limit. To compute the limit, to solve the limit, you have to go a particular methodology, particular theorem. On the basis of that theorem, you will be definitely able to compute the limit. But before going to this type of application over limit, just we go through the informal definition of limit. Limit. Already we defined limit of fx. X approaches to C. C is any real number. Then it approaches to L. Very simply, we can define this concept of limit as limit of a real valued function fx approaches to L as x approaches to C. It means that fx is a real valued function and the limit of fx approaches to L as x approaches to C, where C is a real number. Then what will be the next? How we will approach to compute the limit? How we evaluate the limit? There may be many questions like that. Find limit. Number one, limit x tends to 1, x squared plus 2. This is the real valued function. This is the x approaches to A or C. But what will be the L? You have to compute. Next, limit x tends to 0. The real valued function will be under root of x. Third one, limit x tends to 2 and the real valued function is x squared upon 1 plus x. These are some examples where we need the concept of limit. Not only the concept of limit, but a deep understanding of limit. How we deal the concept of limit over such questions. confirming about limit laws or rules of limit calculations. If you are unsure about your limit laws or calculation of limit, then definitely this will be very trivial to solve. Thus, we deal on the theorem on limit laws. What is the theorem? Because in this particular and uniquely presented theorem, you will get all the limit laws simultaneously. The limit laws or the limit theorem. This one, let L, we can write if L, M, K, and C all belongs to the set of real numbers, and limit of fx, a real valued function, is equal to L or approaches to L as x approaches to C, and the limit of gx, this is another real valued function, approaches to M. Both L and M are the real numbers. Again, x approaches to C, then the followings are the limit laws. The followings are referred as limit laws. Number first, sum rule. Sum. Very simply we can define limit of x approaches to C, fx plus gx equal to, this generalizes over these terms as limit of x approaches to C of fx plus limit of gx x approaches to C. This is directly generalized like that. But we already defined L and M are the real numbers. Thus, we can write for this L and for this M. This is the first limit law. Second one, very simply, this rub and got the difference rule. Without knowing the rule, we are unable to obtain the limit. Therefore, the lecture series on calculus is very important, and its sequence also very important. Next we deal very simply the difference means subtraction. It means the sign will be this fx minus gx. At the same approach, x tends to C. Again, this will be generalized as this limit of fx minus limit of gx. Again, we have the value of fx and gx as L and M. So that directly we write L and M with difference or subtract sign. This is referred as coefficient law. I love this one. Third one is coefficient law or constant coefficient law. Coefficient means constant coefficient law. Very simply, limit of the constant coefficient is k, then k of fx, where k is a constant value, but k also belongs to the set of real number. Then limit of x tends to c, kx will be generalized as k is a constant. We put here limit of fx and x approaches to c. Again it will be written as k, and already we know that the value of this is L. Then we write KL. This is the answer. This is the approach where we define, this is the constant coefficient limit law. Really beautifully and very creatively approach. Because calculus, we cannot never imagine about the nature or the physics. Because everything we see, everything we observe, the change is the very key concept. The change, the variation in age, in life, in everywhere, in tree, growing tree, in flower, in sunrise and sunset. These all are an example of this calculus concept. Fourth one again is very interesting. Product. This is called the product limit class. Limit of fx into gx, and we know that x approaches to c is written as limit x approaches to c for there are two terms, and again this term generalized as fx, and this is the into or multiplication or product side. Then limit of x approaches to c gx. Hence we have already this value L into M. Beautifully this is defined a product limit law. With knowing these law, definitely we will be able to solve those problems. Next one, quotient law. Quotient means division, or we say quotient or division. Wonderfully, this division law also satisfies this limit laws. How? Here again we write fx, and it is divided by gx, means gx is the division. Then there is the division, there is a quotient. Thus this is generalized as limit x approaches to c of fx and limit x approaches to c of gx. Then again an interesting result. Again a very distinctly defined result, as this one is L and this one is M. Wonderfully. Next one. This is the very simply we define the quotient law. Thereafter, power law or index law. Fifth one is referred as power law or index law. What do you mean by power? There is any base and raised by a number, definitely it is referred as power or index. Representing the representing the multiplication cumulatively, or we define by limit x approaches to c, and here fx raised to the power any power. Suppose n is a power, n is a number, then this will be generalized as very simply how we define limit x approaches to c fx n. Very simply we know that this is the very conceptual approach. Limit x approaches to c as earlier n f of x, and you can treat this n not only for this real valued function, but also you can treat this index, this power n as the whole power, like that. And surprisingly, as earlier we have this one L and to the power n. This is again a beautiful output, beautiful result. The final one, this is the final approach. 6. This is the root law. Wonderfully we define the same extension like product, then after cumulatively define power, then after the last limit law is the root limit law. Very simply, this defined by the root of under root of x fx, and I don't have the chalk. Let's try where is chalk. No problem. I will be searching the chalk. Here. Yes. And wonderfully, we define this root law as this nth root of the real valued function fx, and again this not applied only just for this real valued function fx, but also for this whole condition fx. It means 1 by n, yeah, or we define by nth root of this nth root not only defined for this real valued function fx, but also as the earlier, as the preceding rule of power, we can write like that, and limit of x approaches to c and fx, and again creatively, beautifully, a wonderful using these 6 laws, we can evaluate, we can determine, we can find the limit of any expression. Therefore, the already given some problems or illustration, definitely you can do by yourself, and by using this 6 laws of limits. I think you are able to solve any limit evaluation problem by applying these laws or rules. I will show you how it deals with an example. Next, find the limit. Find the limit. What is the question? Limit of x approaches to 1, x square plus 2x. Then what will be the solution? Very simply, here this is a real valued function. Then limit of x approaches to 1 is generalized with this polynomial. Then limit of x with x approaches to 1, x square, the first term. Then limit of x approaches to 1 with the second term. It implies, what do you mean by this? Power rule. Power rule means, very simply we can define the power rule, or limit of x approaches to 1, x is 1 whole square by the power rule, and very simply by the, can you guess the rule? Yeah, there are 2 rules. First is general rule applying the limit, but this 2 is a constant coefficient. Therefore, by applying the constant coefficient rule, we have to limit of x approaches to 1 and x. We know that we have direct value. We can put x approaches to 1 here. Then this becomes 1 as 1 raised to 2 plus again here 2 into limit x approaches to 1. It means the value direct we can put here x is 1, then it becomes 2 and 1. Then finally we have the result 1 plus 2 into 1, 2. Then the 3 is the answer. 3 is the limit value. 3 is the limit value of the function. We can say that 3 is the 3 approaches to, this limit approaches to 3 as x approaches to 1. This is the complete concept of laws of limit and its example. I think you understood well. Thank you.